Hello everyone, welcome to today's lesson on dividing polynomials. Alright, so personally, I find dividing polynomials a bit harder than multiplication, but it is a lot more satisfying because you can see more and more things get cancelled out. Alright, so without further ado, alright, let's do some dividing here. Well, just a quick reminder, a fraction is the same thing as divide. Alright, so this is pretty much the same thing as saying 8xy divided by 2xy. Just a reminder, the division sign looks like this is because that's literally what a fraction is. Right? We got a number on top over a number on the bottom. Hence why we got a fraction sign like this. Right? So yeah, again, whenever you see a fraction, it just means to divide. And to divide, we split all the numbers and the variables up. So we got 8 and 2 here. So that's 8 divided by 2. Right, and then we got x and x, so x over x. And then we got y by itself. Right, so it's just y or y over 1. Right, because there's nothing for y underneath. Right, and we're going to multiply them together. Right, as we can see, 2 or 8 over 2. Right, both of those can be divided by 2 to get 4 over 1. Same thing as just 8 divided by 2. We get 4. X divided by x, they cancel out. Right? Or you can think of it as x to the power of 0. Right? Because with our exponent laws, whenever you divide, we subtract the exponents. So 1 minus 1. And then y over 1 is just y, of course. So our end result is just 4y. Right, so that's how you divide. Right, and of course, it doesn't really matter what the variables are and how big the numbers is. We follow the same idea, right? So coefficients, we split them up. Variable with the same letter, we split them up accordingly. Right, of course, think of it as multiplying all those divisions together. I think I forgot the multiplication signs here. Okay, so once again, let's see. 100 over, oh, why is it 5? It should be 50 here. 100 over 50. Both of those divisible by 50, just 2 over 1. Or think of it as just 100 divided by 50, which is 2. Next, x to the 50 divided by x to the 48. Okay, if you remember exponent law, it's just 50 minus 48. And lastly, y to the power of 15. Right? Again, exponent laws. Exponent of 30 minus 15. Just like that. Okay, so let's give it a shot. So now, in this example, in the first few examples here, right, we got a bunch of terms now. Right? Because before, we just have one clump here, one term divided by one term. But now, when we have polynomials, which is more than one term, we got a few terms together separated by plus and minuses. So now we split them up accordingly. Right, we got this minus that minus that. Right, so notice how the denominator does not change. Right, we're just splitting this into our 3 sections here. Right, so the denominator applies to all of them. Right, because you can think of questions like this as, right, so this whole thing, oops, you can think of it as this whole thing divided by 3. Right, and with our flying arrows analogy from our previous lesson, right, you can think of every single term getting divided by this 3. Right, so that's why we split them up like this. Okay, now let's do our division here. Right, you can see here, you can split them up further if you like. So this becomes like so. Right, so we're just literally splitting up everything into its most fundamental forms. Right, because this is in the same term now we are multiplying. Right, we're multiplying those divisions, just like our example from earlier. Okay, 9 divided by 3 is just 3. a squared is left as it is. We're gonna run out of space here, so let me adjust this real quick. Alright, next we have 3 and a 3 that cancels out. 3 divided by 3 is just 1. So we're just left as minus a plus 6 divided by 3, which is 2. Alright, that's it. Of course, you don't need to show the step. Alright, if you're confident, you can just go from this to that. Okay, next example. Right, we got multiple terms here, so we got to split the fraction up. Right, we gotta stop putting 6 and b next to each other. It looks too similar. Right, so we got 16 16b squared divided by negative 4. Right, and of course, as you can see here, right, this only applies to the coefficient here. 16 divided by negative 4, both divisible by 4, right, is, be careful here, negative 4b squared. Right, a positive number divided by negative is negative. Okay, next. 12 divided by negative 4 is 3. But of course, as you can see here, we got minus 12b divided by negative 4. This becomes plus 3b. Lastly, 8 divided by negative 4 is minus 2. Careful the negatives. Okay, let's make things more complicated. How about a term that you're dividing with has a variable? So same idea, we split them up. 6cd over 3c. Okay? Okay, so we look at the variables, or the coefficients first. 3 and a 9, that gets cancelled out to be 3. Okay, 9 divided by 3 is 3. And now, we notice here that we have c squared divided by c. That's the same thing as c to the power of 2 minus 1. Right? Again, exponent loss coming back. Next, we got 6 over 3, both divisible by 3. It's 2. And now this time, right, we got c and c here. Right, c divided by c is just c to the power of 1 minus 1. D remains because nothing really gets divided into the d. So after all of that, we got minus 3 times c to the power of 1 plus 2d. Right? This is just c to the power of 0, which is just 1. So this is just 2 times 1 times d, which is just 2d. Okay. Once again, we split everything up, just like that. Plus 10. And then, right, just like that, we split everything up. Okay. 25, negative 25 divided by 5. Positive 5. E to the power of 2 minus 1. And f to the power of 1 minus 1. And again, we are dividing here, so we're subtracting the exponents. Next is 10 divided by negative 5. So, of course, it's negative 2. E is 1 minus 1, f is 2 minus 1. Last step, minus 5 divided by negative 5 is just 1. Right? Those cancel out. But remember, the negative signs don't cancel out, so it's just 1. And then e minus 1, f minus 1. Or e times 1 minus 1, f to the power of 1 minus 1. Altogether, 5 to the power of just e. Or, oh my god, what am I talking about? 5 times e. And then 2 times f. And just plus 1. Right, anything to the power of 0 becomes 1. Of course, you can do algebra tiles as well if you like. Right, so in this case, we have the top number here. 2 of the negative x squared tiles. and 4 of the long x positive tiles. We're dividing everything by 2x. So dividing everything by 2x. So now we're saying, what shapes can we put here so that we get all those 6 shapes here? Right? And of course, to get a negative tile, we need something negative. Right? Or more specifically, we need a negative x tile, right? So that this side is x, this length is negative x. Multiplied together, we get negative x squared. And how do you get those guys down here? Right? We already have a length of x up here. We also have a length of x down here. So all we need is just a regular 1. Right? Because it doesn't need to change. It's perfect just the way it is. So this right here, multiplied to our x rod, is still an x rod. So to translate whatever this is into algebra, right, we get a negative x tile and then 2 positive 1 tiles. Just like that. So you can kind of guess backwards too. Of course, word problems. Yippee, fun stuff. The area of a shape is 1 over 2 times base times height. Right, and now we're given the area, which is 54 b squared c, right, equals to 1 over 2. We know the base, which is 9b, right, 9b. And we need the height, h. We don't know the height. So now, how do we find the height, or h? Right, so once again, we have something like, oh, actually, let's combine those two here. Right, just so it's a bit more clear, we got 9b over 2 times h. Right, and now we want to know what h is. And now, in order to do that, right, we know it's h is a result of this big number equals to h times the smaller number. Right, so now what we can do to work backwards is say, okay, if 2b over 2 times h is this result here, then h must be the total area divided by this length, right? We're just working backwards here. Right, and of course, whenever we divide a fraction, we flip it. Times 2 and 2 over 9b. Right, and of course, we multiply them together. Right, think of this as this fraction over 1. 2 times 54 is 108 b squared c over 9b. Right, and we do our divisions here. 108 divided by 9 is 12. Then we got b to the power of 2 minus 1, and then c by itself. So it's 12bc. Here's a cool Millennium Falcon here. It can carry 4x students. And we need to send this many students to space. Very cool field trip. Right? So we can just divide. Alright, this divided by 2x. Oh, it's not 3x, 4x. That's why I fell off. Okay. Once again, let's split it up. $28 divided by 4 is 7. X is 2 minus 1. Minus 16 and 4 divided by 4 is 4 remaining. x divided by x cancels out to be x to the power of 0. So just 7x minus 4. Right? And why do we even do this? Right? It's because, let's say x is 5. Right? If we were just to plug it back in, right, this is the same thing as 7 times 5 minus 4, which is 35 minus 4, which is 31 students. Right, so notice how this is a lot easier to calculate. The 3x minus 4. It's easier to calculate than if we were to plug in, say, x equals to 5 in here divided by 20 down here. Right, so we divide everything first, so it's easier to work with. Or not, wait, it's not students, spaceships. Okay. So now, to end off the unit, here are some provision/extending questions. Right, they are on the harder side of things, but I'm hoping that if you're confident enough to do the harder ones, I'm sure the rest of the unit is no problem. Right, so yeah, give those a shot. Right, but for now, I'm gonna write out all the answers here. Right, so first we notice here, the g's here can cancel. Right, and then we do the flying arrows. So the 2 goes to those, negative 3g goes to those. It's minus 8g. Alright, so notice here, 4g times negative 3g is negative 12g squared. Negative 5 times negative 3g is plus 15g. Oh, look at that, combine like terms. It's literally got everything, that's why it's proficient. I got a g squares here. So 2 minus 12, negative 10. Minus a plus 15, 7. Yeah, what is this? Like, what the heck is this? Alright, let's figure it out. Split them up. Fun fact, in university or grade 12 math, you will see this a lot, h, I, and j. Those are 3 variables you'll see a lot in linear algebra. Okay, so if you want to go into coding, it'll be very useful. I'm a little traumatized from it at university, but that's okay. Okay, let's start canceling. I squared divided by I squared, those can cancel. J divided by J, those two can cancel. Our first one is just h squared divided by h. So 2 minus 1. Oh, J does not get cancelled. H is here get cancelled. I squared gets cancelled. We're left with, oh, no, times here. We're left with plus J, 2 minus 1. I squared gets cancelled. H here is 2 minus 1. And J is also 2 minus 1. Right? Remember the exponent loss here. So, in total, we got minus H plus J minus JH. It's not satisfying, but you get a big discussing fraction here. But all you are left with is this. Next. Oh, we can cancel some things out right away. 7s can cancel it out. 9 and the 3 gets reduced to 3 over 1. So, that 3 gets cancelled out as well because it's a 1. Flying arrows. But 3k cubed, 4k squared, 18k cubed, 9k squared. Combined like terms, 3 and 18 is k cubed, 4 and minus 9 minus 5. Alright, so be very careful here. We're adding and subtracting here. Alright, we're not multiplying, we're adding and subtracting. So we're not doing exponent laws. We are splitting them up with the plus and minus and combining like terms. Very, very careful here. Alright, here's a fun one. A lot trickier. We start off with the fraction, right? We can reduce it. Oh. And now with our next fraction here, there's something that we really have to watch out for. Alright, we can expand everything here, or multiply everything here. Alright, but notice here how we're actually multiplying, there's a minus here, and we got the brackets here. Alright, so we are multiplying this 3L by negative 4L squared. And this 6L squared, we're multiplying by negative 4L squared. Alright, so remember, when we multiply this, we always check the sign in front of it. Right, so the first part, right, we'll need a bit more space here. So the first part is negative L cubed plus L squared. Right, straightforward. Right, but notice how for our fraction now, we actually have minus 12 or minus 12L cubed minus 24L to the power 4. Right, because right here, 3L used to be positive, and now after multiplying by negative 4L squared, now it's minus 12L cubed. 6L squared used to be positive, we're multiplying that by minus 4L squared, now it's negative. Right, so be very, very careful of the negatives here. Right, and as we can see, we got a fraction we can split up. So we got 12L cubed over 3 minus 24L fourth over 3. Cancel this out. This is 4, this is 8. Alright. And of course, we gotta rearrange them based on descending order of power and combine like terms in this case. Minus 1, minus 4. Just like that. Right. Alternatively, there's another way to do this. Alright, or you can notice here that both of those are the same denominator. Right, so we can actually subtract all of them together. Just like how we subtract fractions, right? As long as we have the same denominator, we can subtract them just fine, just the numerators. Alright, so we can start foiling up here. You can see a lot clearer up here that right, we multiply everything by minus 4L squared. Oh boy, gonna run out of room again, I think. Okay, I'm running really big on my tablet, but hopefully I left enough room on the printed out copies. Okay, so this is what everything looks like expanded out. I need more room. Uh-oh. Let's hope this is still legible. Right, we split all of them up. So this divided by 3, this divided by 3, this divided by 3, and this divided by 3. Yeah, I ran out of room here, but actually, I can maybe squeeze it down here. It's getting really sketchy down here. We got negative L3 plus 3L minus 4L cubed minus 8L4. So as you can see, it's exact same answer. Rearrange based on descending power, combining like terms, and voila. Alright, look at that. So, those 4 questions are very much proficient / extending level. It's probably leaning more towards extending, right? Because it combines everything we've learned. So, give those a shot. And yeah, that's pretty much it. So, good luck practicing.